Hello, everyone. Welcome to the Hour of Code 2020. This is for secondary school students, but really it's for anyone who is interested in coding in a text-based language. We are going to be using Lynx coding today as our software platform, and I would guess that probably nobody's ever heard about it before. So I think you will all learn something new today. Okay, so let's get started right away. We've got a lot to cover. And I want to ground us with the reason that we're here, and that is for the Hour of Code. Let's have a quick look at the website. Now, you may have seen this before. I am sure that you have been engaged in the Hour of Code at some point in your school. And it's a global event. Just have a look at the map. I think you'll be quite surprised. So if you look, there's over 1 billion people who have been involved in the Hour of Code over time. And I would say it's probably been running for probably close to 10 years now. But if you look at this map, you can see we're somewhere in this crazy cluster in Southern Ontario. That's our school board involved in this great event that started as a day in December, but has evolved over time, and it's now an entire week. Who knows? Perhaps in the future, it'll be an entire month. But I think for us, it's important that we do engage in this activity because computer science to some people seems like it is this crazy, challenging language that there's no way you can understand it. But once you get involved, you realize it's not that difficult after all. And that is the entire idea behind the Hour of Code. It's to help people see that engaging in coding can actually be a lot of fun. So if you scroll down, the landing page that is in the slide deck is the Canadian page. So you'll see there's some Canadian content, some Canadian links here. And if we scroll back up to the top, the button that says try it, and I do encourage you to try it later, you'll see there are all kinds of activities that are approximately an hour in length and are broken out into different grade levels. If you have a younger brother, younger sister, cousin, you can also show them this website. There's lots of great activities here for our younger friends as well. But we are going to dig into the secondary. And if you scroll down, you'll see there's a big variety of activities here. Some of them are still based in the block coding that people usually start with when they get into coding, and then growing to some text languages. We've got some JavaScript over here. We've got, and again, I mean, there's some pretty good topics here. So you've got something that's looking a little bit at artificial intelligence and machine learning. I saw a Python, right up there. There's a Python up there. So lots of different languages that you could play with. You can also break it down according to which technology you have available to use, the curricular topics, and if there's maybe something that you want to do that's going to last more than the hour, then you can summarize by that as well. So that is the Hour of Code. The other website that you may want to check out is code.org. That is the organization that is the organizing organization for this event. Somewhere in here, and I don't want to waste your time, but have a look later once you dive in. It talks about the different organizations that back the Hour of Code. We always wonder, where do you get the money from to do these kind of events? It is the amount of sponsors they have is unbelievable, and it ranges from Google to Facebook to 20th Century Fox, like all sorts of organizations are backing code.org and this event in particular because they feel that it is so important to engage youth in these activities. All right, so back to our slide deck. The other link in here that's really important is the link to the actual coding language that we're going to be using. This is Canadian. It was a coding language that was created in Montreal. This is the company here. You may have heard of it, or you may have heard of something called MicroWorlds, which is also created by LCSI, and that is their block-based coding. This is text, but once we get into it a little bit more, you'll see it is text and you have to use a text language, but it still uses a graphical interface. So while you're typing in the text, you can visually see what the code is doing. And sometimes that makes the understanding of the code much easier if you can physically see something happening. All right, we'll get back to that in a sec, but let's continue on with our grounding into the hour of code. And we'll do that by watching a video.
We learned a lot in 2020. A lot.
Like how to navigate video meetings.
And that PJ bottoms can count as a school uniform.
We learned new words and phrases.
Like social distance.
And essential workers.
We learned it's okay to feel lonely sometimes.
Or tired.
Or discouraged. We've learned that injustice persists, but so do heroes.
And that more than ever, we're all connected.
But the digital divide is as wide as it has ever been.
We've learned that to build the future that we want, computer science is more important than ever.
So we keep learning.
We learn computer science to predict forest fires and earthquakes.
And to help design vaccines that fight disease.
We learn computer science to connect with each other.
To make art and music. We learn computer science to make sure no one gets left behind.
Because building a brighter future will take all of us.
Hey, this is Phil Harper, and whether you're in the classroom or learning from home, doing an hour of code is a great way to learn computer science. Right here? Hour of code! Yeah!
I love that. I think that is such a nice way to start our activities today. It's been a tough year, and we still have we've got a little way to go. It is getting brighter, as the video says, but there's been challenges, and so it's nice to do this hour of code together and to do something that's positive. All right, so let's get gotta get to the next slide. Sorry about that. Now, this is what we need to do to get started. And this is a slide you may want to come back to. We will go through this together in a moment. You will need to go to the Lynx Coding Club. Once you're there, you will create an account, unless you already have one, of course. And when you create that account, there are different options. My recommendation for you is to use your Google account, which is your @pdsb.net account, because it is a protected account. That's why we've taken your personal information out of that account. So it's safe to use that when you're logging into other websites. And then this is the really important part. If you log in, it is fine. You will have a trial account by default, and it will give you 15 days free use of the platform. However, you at some point, either today or in the future, within that 15 days, you want to upgrade to individual. So you're going to go into your profile. So once you log in, you'll see your profile here. I'm going to show you how to do this. And you will select individual. And it does say that it costs $9.99 a year. But that is if you are a non-Canadian citizen, or if you are not a Canadian resident, pardon me. So if you live in Canada, then you have access to a free account because of some funding that the federal government has given to Lynx. So once you go through that, it will just ask you if you are a Canadian. If you say yes, then that payment is no longer required. So super important, something that you can have for free courtesy of the federal government, and free is always a great thing. Now, this is the page that you will do your coding on, and I know it looks super overwhelming, but let's just kind of break this down a little bit. You've got this is the area over here, the text area where you're going to create your coding. Over here where your little turtle is, this is your work area. This is where you're visually going to see what's happening in the code. You've got your command center down here. So you have two options when you're coding. If you're coding over here in your procedure window, then the code here will not execute until you create an event, let's say, and I'll explain how to do that once we get into the platform. Whereas over here in the command center, when you type in a command, it will immediately execute. Now, this is a nice area if you're testing something out and you want to see what happens, you can type that in the command center, and then you will see the action immediately on the turtle screen or on the work area. The other thing that happens in the command center, when you are running your code from your procedure, if there are any problems, anything that you need to debug, that's this little bug down here, then that will show up in the command center and it'll tell you there's a problem on line whatever, and then you can go in and fix it. Now, the other thing that I really want you guys to know, because you are going to be upset if I do not tell you this, where this little cloud is, you need to save regularly. This does not auto save. And for all you Google users out there that are used to the auto save whenever you're using the Google tools, which is an amazing feature, this unfortunately doesn't have it, and you have to remember to save. There will be like a little red dot up there that just gives you a warning that you haven't saved for a while. As soon as you see that dot, just click on this cloud and it will auto save for you in the cloud. That's the idea of that cloud there. Your plus is where you can get pre-made objects as well as clip art. This is where you can get some samples. So when we dig in there, you'll see there's lots of programs that have already been created. And sometimes that is the best way to start in a new language. Look at something that's already been created and try to understand the syntax and what's happening. Right here, this is how you can kind of looks like a keyboard. That's how you can come back to this procedure window if you open up one of these other areas in your menu bar. Over here, this is your home. I don't really understand the image, but basically this is where you are creating your bank of clip art that you're going to be using in your coding. And the project tree, this is really, really important. You're going to be putting different objects. So your turtle right now is an object. You're going to be putting other objects on your screen. Could be buttons, could be clip art, could be sound. All of those will be available to you in the project tree, which is really important because you may turn one of these off. It may be invisible, or you may scale it so small that you can't see it anymore. You can still access through the tree. Now down here, these items are not as critical as your programming, so that's why they're at the bottom. These are your preferences. So you could change your font, you can change, there's a beginner mode and there's an advanced mode. Just basically will change the amount of commands that are available to you. And this will bring you back to your main landing page where all your projects are. You've got some tutorials here and some other help down here as well. So there's lots to digest there. I will show you once we get into the platform a little bit, but it's good to have an idea overall of everything that's available to you. So this command, when you put some programming in it, and I'm just going to give you a look at commands. The beautiful thing about many of the programming languages is they are written in a way that's very similar to whatever language you're using, whether it's English or French or Spanish or whatever the language is written in. The words are very similar. We talk about something called pseudocode, where you're putting in words when you're writing out your ideas of how you're going to write your code. Pseudocode is like, I'm writing down what I'm going to program, and it's not quite English or whatever language you're using, but it's pretty close, and that's what we've got here. But this is actually the commands, which is nice. All right, so if you have thought about that, let's have a little look to see what it does. Okay, so is that what you thought? Let's go back. So this code says forward 100. So we've got a little turtle right here. And the idea in this language, and there's other languages that use turtle programming as well, when you are giving commands, you are telling the turtle to move. And that turtle, if you could think of him as holding a pen, as he moves, as long as the pen is down, where his movements go, the pen will follow. So let's go back again. Now that you know that, forward 100, pen down. And this is important. With Lynx and other languages, most languages that use turtle, they are written using Cartesian coordinates. And Cartesian coordinates is just basically XY axis with the 4 quadrants. And I'm going to show you what that looks like. But the center of the Cartesian plane is 0, 0. So knowing that, if we're telling the turtle, move forward 100, pen down, we can see the turtle starts at 0, 0, that's the home, moves 100, and the pen is put down onto the page. Now, what's the next thing that happens? Repeat 4 times, and this is what repeats. Go forward 100, and just so you know, 100 means 100 pixels. So go forward 100 pixels, turn right 90 degrees, pen up. Let's have a look. We talked about the turtle moving forward, pen is down, it goes forward 100 pixels, turns right 90 degrees, forward 100 pixels, and repeats that 4 times to create a square. Now, if we put the Cartesian map on there, we could see the 0, 0. We know the turtle moved forward 100 pixels, and then we put the pen down and it moved forward another 100, turned right, moved forward 100. So knowing that, looking at this graph, can you guess what your maximum, you've got your positive X, your negative X, positive Y, negative Y. Can you guess what your maximum coordinates are at each of these quadrants? 1, 2, 3, 4. Give you a second to think about that. There you go. Is that what you thought? So look here, just visually, just proportionally, you've got 100, 100, you're pretty close to the top. That looks like about a quarter, right? So you've got 225, that's the maximum X position, right? And then for your Y, you've got 100. And if you think about another 100 visually, another 100, another 100, you can kind of guess it's going to be 400. So how it works is this corner right up here, the position that the turtle would be in this corner would be 225. That's the X coordinate value. And 400, that's the Y. So, or sorry, that's the Y, that's the X, sorry, backwards. So there you go. That gives you an idea, really important when you're doing your programming so that you have an idea where that turtle is at all times, because that's the idea of turtle programming. It's using those pixels, those XY coordinates to do your coding. All right, so looking at the code again, when we put it in the command window, as we talked about a few minutes ago, in the command center, the code will activate immediately once you put the code in there. Now, in the procedure window, once we create the code and we want it to execute as soon as the person opens the window, how do we get that to execute? What is the trigger? We need a trigger or something that's called an event. So how can we trigger that code? Well, if you look at the procedure and you look at that window below, you can see there are lots of ways to trigger a procedure. But in this case, what we've done is we've put in 2 buttons, one called start, one called reset, and we've used those buttons as the trigger to execute the program. So this one we already know, we discussed. Basically, once the button is clicked, then this code will activate. The button 1, which happens to be the start, and then button 2, once it is clicked or pressed, then it will clear the screen, we'll take the turtle back home, procedure is complete. All right, so important thing, you're writing all this code, how do you get it to run? You need to have an event or some sort of a calling procedure in order to execute that code. Okay, I'm going to make this big screen. Well, I'll play and then I'll make a big screen. This is the code that I have written and I'm happy to share with you. We're not going to be able to get deep into it, but the idea is that with this code, you can use it to, well, there's lots of things you could do, but one of the things you can do is create a story. And so think of your English class or your history class or one of the subjects you're taking. And so often you are asked to present your material. Well, have you ever thought about presenting it through code?
Nothing could go wrong with this day. Got you.
Okay, so a little morbid, but it gives you the idea. You can, and then this is pretty simple coding. You can create a story with multiple pages in the Lynx programming environment. And I do, at the end of our hour of code, I do invite you to play around with that a little bit and see if you could create your own story. Now let's jump into Lynx. To create your account, it'll say login, register here. So let me log out, I can show you. You want to log in, and remember my recommendation, log in with your Google account, up to you which way you want to go. But once you do that, it's just single sign on. There you go, you're in the program. These are some of my programs that I've already created. You will, at some point, want to go to your profile and right over here. So it'll show you what your current subscription is. It'll be trial once you first log in. You're going to want to change that. And you will be over here with the trial. You're going to want to select the individual. And then once you do, I have already done it, but once you do, oh yeah, it's going to ask you this information down here. This is because the government will pay for your subscription, but you do need to put in your postal code and your gender. I think that's all you need to put in is those two pieces of information, and then your account is created, and that's fine. You will not have to pay the $10 a month. You will be good to go. Let's look at my projects. There is a very simple one I would like to show you. When you click on a project, you're going to be on your if you want to think of it as your play screen. So from here, I can just execute the code. I don't have to go into it. I have all of these different options down here. If you do use Lynx to create a project that you want to provide to, like I said, to an English teacher, whatever teacher it happens to be, if you click on share, you're going to get a URL link. Create. You're going to get a link, and you can submit that link to your teacher. They don't have to know how to use code. It doesn't matter. Once they click on that link, it's basically going to bring them to a page that looks something like this. And from here, let me just reset this code. From here, you can see my turtles way down there. I can press start. I put the buttons in here and click execute the code. Now, obviously, if you're going to do this and you're going to submit it as a project to a teacher, you would want to add some text over here just to give them some instructions so they know what they're supposed to be doing once they get to this page. Let's look at the code, try to figure out, oh, I should show you one more thing. So basically you saw that turtle, when I hit the start, it was creating these boxes. The other thing you probably noticed is once I clicked on the turtle, it was changing the color of the turtle as well as the object that the turtle had just created. So keep that in mind once we dig into the code to see what's going on. The other thing that's here is a URL link. This is something else you can do in the language. And basically it will just open up a new tab and it will take you to whatever URL link that you program into the code. Okay. So let's have a look. If we go into edit, that will bring us into the coding environment and we can have a look and see. Now there's not a lot here, which is good. This is good. It's not overly intimidating, right? So what have we got here that we talked about before? We've got the cloud where we need to save our program if we're making changes. We've got our plus, which gives us, these are objects. If you've coded before, you will know that word object. It's used in programming all the time. So you've got all of these different objects that you can add to your program. Right here, you've got your projects. You can bring in samples. I'm just going to show you. Here are many samples that have already been created and are in the code for you as a starting ground. You can pull those in. This brings us back to this procedure if we've got something else that's open. If you click on the house, these are the clip art images that I have brought into the program. You can, so if you click here, there are sample clip art that you can bring in to your clip art window. You can also add in your own. So if I click on a plus within, these are my files basically, I can either bring an image in by linking it to the URL site. I can select something that's on my hard drive. I did download, let's see. Okay, perfect. There you go. There's an image and create. So that brought the image in here. The other thing you could do is you can, if there's an image that you have open, let's see. Oh, you know what? Let's just go back to the slide deck. So let's find an image somewhere in here. Let's just take this image. So copy this image. Can I, oh, let me get out of the presentation mode. If I copy an image, then I can take that image and I can just paste it directly. I can paste it directly into the platform. So copy and go back into Lynx, click on my window and Control V will paste. Ooh. Oh, let me think it's too big. So give it a try. You will need to have a smaller image to do that. But you could just copy and paste directly into the window. If you're using maybe some sort of graphic paint or something like that, you could create an image and just copy, paste it directly into one of your sheets. Now, project tree, once you click on it, you'll see if you've got multiple pages, we only have one page right now. But if you click on the page, here are the objects. So just so we understand what an object is, our T1 is our turtle. If I right click on the turtle, I could change the name of the turtle. That's fine. This is just the default. I could change the location, the XY coordinate, and here are events. So the event that I created that you saw when you click on the turtle, the color changes, that's the on click event. So the event is called T1 click. I have other events that I can use from the turtle. If the turtle touches something, if there's a message, if there's a color that the turtle touches, these different events can trigger. And this is where you can make your objects visible or invisible. You can freeze them. If you have made it invisible, see, notice I've lost my turtle. I can't find my turtle anymore. The only way I can access is to come over to this project tree and click on my turtle, and then I will be able to access the turtle again. I can edit and make it visible. So I see my turtle once more. Your other objects, you've got your two buttons, you got your start and your reset. And I have the hyperlink right over here. Again, edit, I can change that hyperlink. I can make it invisible, change the name or don't, or sorry, show the name or don't show the name, or freeze it. Now help down here, I'll let you guys explore that on your own. Let's go back to procedure so we can see what's going on. So we saw when we press the start, this is what we looked at in the slide deck, the start button, there it is. The start button triggers this part of the code, which basically draws a square. The reset button, what it does is it sets the position of the turtle. Now, what is that position? 0, minus 225. If you remember, we talked about the Cartesian plane, the Cartesian map. So the 0, that's x is 0 and y is minus 225. That brings the turtle right down here. Remember at the very beginning, you just saw the little head of the turtle. So it brings the turtle right down here, which allows us, reset, it allows us to start at the very bottom of our screen and build up from there. So we're moving the turtle back to the lower position in the window. We clean the screen, we get rid of all that stuff that's there. Obviously the objects are not part of that command. We set the color of the turtle to black and end that part of the program. Now the T1 click, that is the turtle click. If you remember when we looked at the turtle object, we saw there was that command or that trigger there, the T1 click. So that's what that's all about. When you click the turtle, you're going to set the color to a random color. 255 represents the number of colors that it could go through. So if I made it random 100, then it would choose a random color between 1 and 100. And we're not going to talk about colors today, but colors all have a different value inside any programming environment. So that's where that number comes from. It's going to go back 1, right 98, forward 1, and fill. Now, what the heck am I doing here? This is because the way it works, let's start it. If I want the turtle to fill the color in here, the turtle has to be within the object to fill it. If I left the turtle right on the corner, it will not fill the color. All it will do is it will color the line. I want it to fill everything within that square. So I actually have to move the turtle inside the square. So I could have moved it anywhere within that square that was just created. I chose just to go back 1, turn right, go forward 1, and it just brought the turtle into the square. I fill it, and then basically I turn him back around and bring him back, or her, to the top corner of that square. So that's what this is doing right over here. And when I click start, again, it will execute this part of the command up here and draw another square. Okay, so that is basic programming in this environment. So how do I know where these commands are? I'm lost. I don't even know where to start. Well, let me show you. There's a couple of things that I put in the slide deck for you. One is a website which is full of sound effects. If you want to add some, like I had da, 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 in my little video. If you want to get sounds like that, if you go to this website, there's lots of them there. And then the Lynx coding commands. This is the PDF that has all of the commands, are called primitives, has all the commands that are available to you inside this environment. There are around 150 commands, I want to say. But if you are in Lynx itself, if you go to your help down here, and you've got these 3 categories, turtle and graphics, text stuff, other stuff. If you click on the turtle, so this is your drawing, this is where you're probably going to start. It will show you the commands that are applicable for turtle movements, for states, drawing. If you select any of those commands, it will give you some more information, and it will give you an example of what to or how to use it. So that's one way you can get that information when you're inside the environment. The other thing you can do is use the help. And if you search for a command, maybe you know that you want to do a certain command, type it in, And then you will have some articles that will help you with some more details that are related to that command. But really, the best way to start programming, like I said, is to grab one of those samples, right over here, one of the samples, bring it in, see what that sample is doing, just like we did with the code that I wrote here, just to help you understand how the commands work and the structure of this programming environment. All right, so let me open up that other project for you. Notice I had to save. I was given the little red circle here just to indicate that I better save my code. So that's done. I don't have to worry about that anymore. I do want to go back to my project window. And I want to show you, because I would love, you guys can do something like this moving forward. This is what I showed you earlier, just to reset it. Okay, and just to show you again what it does.
Nothing could go wrong with this day. Got you.
Okay, let's see what's happening in here. So this looks a little bit more intimidating, but if you look at the commands, they're not that hard. They're very, very repetitive. The biggest part, and I'll be very honest with you, the hardest thing in this project was just getting the size of the graphics correct so that they didn't look silly. So let me show you what I did just to try to help me out a little bit. I created this table, and in the table I have all of my graphics that I pulled in. I'll show you where they are. And I looked at the size of the graphics. So let me show you how you would do that if you haven't done it before. So Shark. And so what you would want to do is select images. And then I chose, just because we want to be careful of copyright, I chose Creative Commons licenses. That means they're free to use. And the other thing that I did is I wanted it to be a transparent image. Otherwise, if it's not transparent, you're going to get everything, all the background onto your image, and it's just not going to look very good. So you want to have something that's transparent. And what I mean, if you haven't used that before, you could see by these hatch marks at the back or the grid, this is the background that is removed, which just gives you the object in the foreground. That's exactly what you want. And the other thing, see right at the bottom here, I have this number. This is the pixel number. This tells me how many pixels this image is. So this is actually a really big image. It's 1818 pixels by 2400 pixels. So what I did in this table, I have these images that I pulled into my project. I looked at the XY coordinates, so I just showed you, and I put them in here because I wanted to sort of visualize how big my graphics were going to be in respect to each other. So I could see right away the fish image I pulled in was very large compared to some of the other. Actually, these two, the umbrella and the fish, they're almost the same size. They're just one is portrait and one is landscape, but they are pretty close to the same. This is the same image, it's just rotated, but the beach image is by far the smallest image here. So when I did the scaling inside the project, I had to do the scaling based on that. Now the set size, which is your command, set size 40 is normal size. That's just the way it is. So if I say set size to 50, that means that I am setting the size of this image beach a little bit bigger than the normal 500 by 375. And remember, we talked about how big your screen is inside Lynx. We talked about the fact that it's 225, 450 is the maximum at the top corner. So you think about the size of your screen, the size of your image that you're bringing in. Do you want to scale that image up or do you want to scale it down? This image, I wanted to scale it up. So I scaled it up 10 by 10, and it's just a number. There's no units. So I scaled it up by 10 because I wanted to be a bit bigger. So that's where the 50 comes from. The umbrella, look how big it is. I want that to overpower my beach. I have to make it smaller. So I scaled it down. That's why I gave it a number, a set size of 20, which is half of the normal size. So I scaled it down by 20, so it reduced it by 20. So I did this, and this may be helpful to you, maybe not. Maybe you could just visualize it. But for me, a good idea of where I needed to scale things up or down, and to be very transparent with you, some of this is just playing with the numbers until you get the image to look right. So let's go back, and now you can see where all these set sizes come from. That's that table that I just showed you. So what's happening here? We've got a button start, and that's the trigger. So the button is going to show text, and if you hover over these commands, it'll show you what they do, and it'll give you, sometimes it'll give you little tips. So this is an object. Let's look at the objects first. These are the objects that I have, and you can't see them because they're hidden, but I have the sound effect. I edit the sound effect. There it is. And so the sound effect is invisible. I clicked off the visibility. I have a start, a reset, those are visible. The turtle is visible. Basically, this is a turtle. And the turtle, I just keep changing the image all the time. I move it and I change the image. So that's the turtle. And then the text is hidden at the moment, but you saw the text was up here. We'll play it again, but you'll see the text appears up here. It's hidden at the moment. But those are the objects. So in the code, oh, I guess I should show you the clip art as well. So these are the different clip art images. So remember, this image was huge. This was a fish, and the umbrella is pretty big. This is the smallest. And then these are the other two images that it's the same image, it's just rotated. So what happens? So you open up the text box. In that text box, you print, it is a nice quiet day on Lake Erie. We're setting the shape of the turtle to 1. What is 1? 1 is the beach. Okay, so we set the shape to 1. We stamp it, which means we put it on the background, and stamping makes it permanent because remember, the turtle moves. So you don't want the turtle to move. We want the turtle to be on the page. We want it to stamp its image, which is the beach in this case. And then we're going to move on. So we change the turtle again. We're going to change it to the image number 2, which is the umbrella. We change the size. Now we have to scale it because it's too big, and we stamp it. Now we move our position. So the turtle is 0, 0. So this image is 0, 0. The umbrella will be 0, 0. That's where it gets stamped. Now we want to move the turtle over to a location that's just over here, right over here. We're going to set the size of the next image, which is image number 4, which is the fish. Remember, the fish are really large. So that's why the set size is 10, because we really want to reduce the size of that image. Remember, 40 is normal. So we're scaling it down by a long shot. And then we're going to stamp it. We're going to wait for 5 milliseconds, and then we're going to say something. Okay, so if you continue going through the program, you get an idea. It's pretty clear. We play the music. I think most of these are very similar, except this one right here, the glide, is where you see the shark. This shark here lands somewhere around here on the page when it comes in, and then it glides up to this position to look like it's chasing after this beach person here. And then say is the voice of the program. It's pre-programmed into Lynx. It's the voice of the program, so you will physically hear something. Let me reset it again. Oh, there we go. So when I hit reset, this announcement pops up. It's just a trigger. It's just telling me what to do. So that's this down here. So the reset button will clear the graphics. We'll change the shape to 1, which is the beach. Set the size to 50. That's why I've got an image that's a little bit bigger than the actual image. It'll stamp it. So basically clears off the entire screen, stamps with the beach image. So we're resetting back to normal, makes an announcement, which is this right here, that dialog box, which just gives the user an idea of what they have to do to get started, which is basically get rid of the announcement box, press start. Okay, I got it. And there we go.
Nothing
There's
could go
the text
wrong
box.
with this day. Got you.
Okay, and that's the program. So we covered a tremendous amount of material today. I hope that you will be able to jump in now and do a little bit of programming yourself. You may have to come back to this video and watch it again. There's lots of other videos that are available within Lynx and on YouTube that will also help support you get started in this. But I do encourage you to do something similar to the program that we just looked at now, where you are creating a story. And often when we're coding, we will do, we talked about it a bit earlier, we will use pseudocode or, basically English, but not with all the words. And we will write out what we want to code, or we'll draw it, storyboard it, so we have an idea of the graphics that we want to put in place and how that story is going to play out as we work through the code. So think about that. What do you want your story to look like? What objects are you going to need to bring in? What sounds are you going to need? Sound objects. And once you've got all of that background in there, you can start to develop your code, play with the size of your shapes, the positioning of your screen. If you are really comfortable with this environment, I encourage you, try adding some more pages. So the idea would be you've got this part of the story, you click on the next page, it'll tell you the next part of the story, just like a book. All right, thank you, everyone. One last thing I would like to say about the Lynx environment that I should have mentioned at the very beginning. For anyone who may be a French immersion student or somebody who maybe French is your first language, you can switch the language of the Lynx environment over to French. And the entire project, all the commands will be in French, so it's totally bilingual. The other languages that you can look at are some of the First Nation languages, and it's not all of the words will be switched over. Some of them don't translate, or you need to know the English to be able to still use the project. But pretty interesting to see some of the language that some of our First Nations use, some of the more common languages. So have a look at that. It's really interesting. You will not find any other programming language out there that you could switch over to First Nations language. So pretty neat. And the other thing I wanted to say, the last thing I promise, there will be a project moving forward to teach Lynx to elementary students, and we're hoping to get some high school students in, offering some volunteer hours for you. So if you love this environment, programming in Lynx, you are interested in supporting some elementary students so that they can also learn, then please let your teacher know. We would love to have you as part of this project. Okay, everyone, I thank you so much for joining today. It was a whirlwind for sure, and I encourage you now to create your account, to jump in and share with me what you created. I can't wait to see it. Have a great day.